Hi, Russ Shomberg. I'm a marine research engineer from the Graduate School of Oceanography at University of Rhode Island. I'm out here on the National Geographic Lindblad expedition to the Antarctic Peninsula, and we're collecting data on icebergs. This is an instrument designed to do coincidental and simultaneous scans of the sail, the upper part of the iceberg, and the keel, the lower part of the iceberg. So we've got a 12-foot rigid vertical mast that has a sensor payload on the upper part and down on the lower part. On the upper part, we have two cameras just like this, and then this is actually the lower part where we additionally have a multi-beam imaging sonar used to look at the iceberg using sound. This has a much greater range underwater, whereas the cameras have really good angular resolution and can pick up color and lots of detail. We have a way with an AI-based algorithm for fusing that information together while doing the 3D reconstruction of the actual iceberg and taking advantage of both of these strengths of these two different sensors. There's two parts to the software. The first is that we have the control software for running this system. The cameras are USB controlled and the sonar is IP controlled. They're both powered separately via drone batteries, and then communication wires come to my laptop right here. And I've got a Python script that runs these two simultaneously. The important part is that we use the upper cameras for photogrammetry and also for positioning of the rest of the rig. And so all 5 of these sensors need to trigger simultaneously. So there's a software trigger that tells them all to fire at the same time, and then the data collection pulls all of the data off of each of them, and then they fire again. They fire about 10 times a second, so we have to move slowly around the iceberg and make sure there's lots of overlap between the different photographs. And then post facto, there's analysis software, some for just looking at the images. We do some contrast enhancement. We segment out the iceberg so that it's isolated from the rest of the environment. And then we use a piece of software called Colmap in order to do photogrammetry of the upper portion, which is then with some robotics code used to transform to get the positions of the sensors on the lower portions. And then that's fed into some work from some colleagues of ours at the University of Maryland in the computer science department, who have developed a AI-based reconstruction that uses multimodal sensor fusion in order to put together information from both the sonar and the cameras at the same time and feed into the full reconstruction. Absolutely blown away by a couple of things. One, the capabilities of the Endurance. I've been to sea on a lot of research vessels. I have been to sea on ships that are half that size and not even half as maneuverable. It's absolutely amazing the abilities that this ship has. And then as far as Antarctica, I'm blown away by the concentration of nature here. The huge mountains directly pouring into the sea, you know, the amount of wildlife that is just everywhere. It's pretty insane. There's a couple penguins right there interrupting me. We've done quite a bit of work in the Arctic. It's a much more desolate landscape, at least where we go, and this is a pretty insane place to work. And finishing off a day of research by hanging out in the hot tub is not too bad. I want to thank the staff here. Even though this is a dual-use ship, the staff on the Lindblad on the Endurance has been incredibly helpful to us, making sure that we get out every single day, have plenty of time to work on our research, and that's just been fantastic. All right, so this is the lower end of the of the mast, which has the lower payload. What you have here is two different cameras, a larger camera. This is our upgraded version of the camera, and then this is our older version of the camera. Both of these are in Blue Robotics underwater housings. They go down to 300 meters, but we're not really using them for that full use, but they provide waterproofing and keep the cameras nice and protected. This one in the center here is a multi-beam imaging sonar from Blueprint Oculus. This runs at either 1.7 megahertz or 3 megahertz, well above the hearing of any marine mammal, and has a range of up to 30 meters with a range resolution of sub-centimeter. So it has the ability to, within a fanned out angle, fanning in this vertical direction, go 135 degrees in the lower frequency and 60 degrees in the upper frequency. And it can tell both the range and angle of any objects that are far away, which can then be reconstructed. The cameras can work in stereo or separately. We use them for photogrammetry, which means we have lots of overlapping images, which we find matching features in. And then those features can be used to create stereo views and create triangulations for a 3D view.
You got a box down here?
Yeah, the box down here, this is just a battery box. It's got 2 drone batteries in it, providing 12 volts for the cameras and 24 volts for the sonar. So those, along with USB cords for control. This one's actually Ethernet for the sonar, USB for the cameras, and the power all come up, along with up the mast into this power and control box here. All this is a junction for both power and USB. All of the USB control cords for the cameras go into these 4 waterproof plugs and into a USB hub that is powered with the 12 volts separately. That comes out to the computer here, and then the sonar just goes directly to the computer. Up on the top of the mast, we have we just have 2 more cameras, the same type of cameras in Blue Robotics housings. These are USB controlled cameras. They're made by Teledyne. They're the Blackfly version, and so they're entirely software controlled. They have no output display, no buttons on them, and in fact, I better not actually. So they're controlled by the computer on the other side through either the custom script that I made or some GUI software for testing and things like that. Yeah.
That's pretty good.
All right. And we added handles to it.
Yeah. All right. Yeah.